today we are going to talk about other frames also. So there are basically two types of frames. One is inertial, another is non-inertial. Inertial frames are those frames on which Newton's law is applicable. So today we will talk about the frames, and then we are going to observe motion of different particles from different frame. So I'll tell you how to switch frame. So from inertial frame, when you go to non-inertial frame we cannot directly apply Newton's law of motion, so we have to do a small adjustment. So how that adjustment is done, how are the terms involved will come into picture, that we are going to discuss today. So let's start. So go through the definition of the inertial frame. Inertial frame basically a frame from which you can apply Newton's law, or in a simple language if I say, if I observe a particle or body from inertial frame, say this is inertial frame, and I observe that there is no net force acting on body, so net force acting on body is 0, and I am also observing that acceleration of body with respect to frame is also 0. These type of frames are called inertial frame, right. So it looks very obvious that we are not getting any force, we should not get any acceleration. But when we go to non-inertial frame, it might be possible that you are not observing any force but you are getting acceleration, or you might not observe any acceleration but you are getting net force. So if this is not matching, the type of frame we are standing on will be non-inertial frame. So this definition of inertial frame: an inertial frame of reference in classical physics possesses the property that in this frame of reference, body with 0 net force, look at this one, body at 0 net force does not accelerate. So acceleration of body must be 0, right. And all non-inertial frame will have same type of relation with respect to other inertial frame, right. So if from one inertial frame I am going to observe any other inertial frame, then I won't observe any acceleration to that second frame or any other frame, right. So from one inertial frame, when you observe any another inertial frame, then you are not going to observe any acceleration, right. If this condition is not satisfied, then the frame we are standing must be non-inertial, right. So non-inertial frames, see, a non-inertial frame of reference is the reference frame that undergoes acceleration with respect to inertial frame. So I already clear the definition of inertial frame. How to check whether frame is inertial or non-inertial? We have to check this condition. So we have to check this condition whether this condition is satisfied or not. If this condition is satisfied, our frame will be inertial. If this condition is not satisfied, our frame will be non-inertial. So all non-inertial frame will have acceleration with respect to inertial frame. So say I have got this inertial frame, let that be S, and from this frame I observe that another frame, say S dash, is having some acceleration. So as this frame is having acceleration with respect to inertial frame, it is called non-inertial frame. So this is the first point, all non-inertial frame will have acceleration with respect to inertial frame. Second point, while the laws of motion are same in all inertial frame, in non-inertial frame they vary from frame to frame. This we will understand later, right. So, laws of motion what we are applying from inertial frame, that we won't get in the same format if we apply laws of motion from non-inertial frame, or I can say non-inertial frames are those frames where Newton's laws are not directly valid, right. Now, another point, in the classical mechanics it is often possible to explain the motion of the body in non-inertial frame of reference. So, if I want to observe the motion of the body with respect to this frame, non-inertial frame, then I need to do a small adjustment. That adjustment will have the unit of force, that is why that adjustment is called fictitious force or pseudo force. So, by introducing additional fictitious force also called pseudo force or inertial force. So, directly Newton's law is not valid from non-inertial frame. If we want to apply Newton's second law or Newton's laws of motion from non-inertial frame, I have to do a small adjustment. How adjustment is done, we will derive that later, but for time being, if you are on non-inertial frame, you cannot directly write F is equal to ma, where F is the real force, right. What is the meaning of real force and pseudo force, that we will see later, but I hope these 3 points are clear.